Hi and Assalamualaikum. We are from group EEE 1115C. My name is Mio Syaminuddin bin Mio Shazali.
I am Muhammad Ali bin Azman.
My name is Muhammad Haikal bin Hanafi, and our title is Speed Tester. Today I will introduce to you the Speed Tester project, which is designed to measure and display the time taken for specific action or event with precision. This system was developed using the HCS12 microcontroller, programmed in assembly language to achieve accurate timing and responsive performance. It integrates a push button as the main input to start and stop the timer, a buzzer to signal when the timing has stopped, an LCD to display the record time clearly. The project is a great example of combining simple components with fundamental microcontroller programming principle to create a practical and efficient tool. It is particularly useful in educational and experimental settings, allowing for performance and reaction speed analysis. Next, let me walk you through the objective and key features of the Speed Tester project. For the objective, the primary goal of this project is to measure and display the time taken for an action or event with high precision. This makes it highly useful for performance analysis, whether in educational, experimental, or practical applications. For the key features, the project leverages the HCL12 microcontroller, ensuring accurate timing and smooth functionality. Second one is it built entirely using assembly language, allowing precise control of hardware components. This feature showcases the project's emphasis on simplicity, precision, and efficient use of microcontroller capability. Now, let's look at the hardware components that form the foundation of the Speed Tester project. The first one is HCL12 microcontroller. This serves as the core processing units, managing all of the operations, including timing, input detection, and output control. The second one is push button. It acts as the primary input device, used to start and stop the timer. The third one is buzzer. Buzzer provides audible feedback when timing stops, making it easy to recognize the end of an event. The fourth one is LCD. It displays the recorded time in a user-friendly format, ensuring that all the results are all clear and easy to interpret. These components work seamlessly together, showcasing effective microcontroller integration and ensuring accurate, responsive performance.
This circuit represents a speed tester system that uses the HCS12 microcontroller as its central processing unit. The design allows the measurement of elapsed time between two events, such as a reaction time or an activity duration. This process is controlled by two push buttons, switch 2 and switch 3, an LCD for display, and a buzzer for auditory feedback. Referred to the image, we have switch 2, which is a start button for our system. When switch 2 is pressed, it sends a signal to the HCS12 microcontroller to start the timer. This marks the beginning of the measurement process, whereas for switch 3, which is a stop button, sends a signal to stop the timer. It indicates the end of the measurement and the elapsed time is recorded. HCS12 microcontroller acts as the brain of the circuit. It performs several tasks, such as detect buttons for switch 2 and switch 3, manage the internal timer functionality to measure elapsed times, send the measured time data to the LCD for display, activates the buzzer when switch 3 is pressed to provide feedback that the timer has stopped. Next, we have a LCD display. The LCD is connected to port K of the HCS12. It is used to display the measured time after the timer stops. This provides clear visual feedback to the user. Last, a buzzer. The buzzer is activated by the HCS12 when switch 3 is pressed to signal the user that the timer has stopped. This serves as an auditory cue to complement the visual output on the LCD.
So how this device works is the program will enter wait state ping until the start button H3 is pressed. Once started, the timer increment every second, playing the elapsed time in a minute and second format. If the stop button H2 is pressed, the program pauses and plays a buzzer tone before resetting to the original wait state. This code implements a basic countdown timer on a HCS12 microcontroller. It initializes the LCD, set up a loop to increment time every second, and display the update time in a user-friendly format, updating both minutes and seconds, and it will continue running as long as the system is powered. The conclusion is the speed tester project successfully utilized the HCS12 microcontroller to create a reliable and accurate speed measurement system. It demonstrates the importance of assembly language for precise hardware control and show how simple component can achieve complex function. The project delivered consistent result and provide valuable lesson in hardware interaction and debugging. Future improvement could include storing multiple results, adding wireless communication for data logging, or incorporating a graphical display to enhance usability and functionality.